Hi guys, and welcome to this training session where we're going to take a look at the different types of valve bodies that are available from Drayton that you can use with our range of TRV heads.
So here's the range lineup with their respective 15mm angled bodies. Now the RT212, that's going to have the fixed flow rate body, whereas the body on the TRV4 and the RT414 is going to have the variable flow rate body. That's the body that you're able to replace the gland seal on and also balance. So let's have a closer look at this fixed flow rate body. So begin by removing the head. So turn to maximum, and that will take the load off the pin, and then unscrew the locking ring, and that will detach the sensing head from the valve body. So key features about this valve body, you can see it's got the hex nut on the top, and that's what's used for locating the sensing head. Underneath, that's your input. That's pretty much the same as all bodies, but you can see here on the output it's wide open, so there's very little resistance that's being added as a function of using this valve body. Now these hex faces, these interlock into the underside of the head. You can see that they sit in there, and that's what gives you your various positions. So when you're set to maximum, the pin's all the way up, so you should be able to pick where you want the head to sit, and then once you're happy, you can then do up the locking ring. Now from a body orientation point of view, you can see this has got the double-headed arrow, which means it's a bidirectional body. So you don't have to observe any flow direction arrow. The water can either come in and go down or come up and go out. Now the 15mm angled body that's shared by the TRV4 and the RT414 is also bidirectional, and this is the EB valve body. So if we set this one to maximum and remove the locking ring, we will then see the difference between the fixed flow rate body and this one. So here we have a replaceable gland seal, but also an insert that you can rotate in order to balance the system. You can see the numbers that are stamped in. Those refer to different sizes of aperture, getting progressively bigger from position 1 to position 6. Now also on the top we've got these serrations, there's 72 of them, so this gives us really quite fine precision on the direction that we want the head to sit with respect to the valve body. The 414 has the same 15mm angled body, and if we do a side-by-side between this body and our fixed flow rate body, you'll be able to see the difference. And immediately you can see the aperture on the output of the variable flow rate body is much smaller, so we're already building in some resistance to help balance the system. On top you can see the fixed flow rate body has a gland seal, but it's not replaceable, whereas it is on the EB body. The range of our 15mm compression, which suits a 2-pipe system, comprises of your 15mm angle and straight. We also do corner angle valves as well, so this is where you want the head to remain perpendicular to the body, but the pipework comes out of the wall. And we also do a 10mm reducer for microbore, which is a bullet connector, which you can see me install in section 3 of this module. So just a word here on flow direction. So this is our 15mm angled EB body, and you can see it's got the double-headed arrow, just like the fixed flow rate body, which means you don't have to worry which end the flow is coming in. It can come up the bottom and go out the side, or come in the side and go out the bottom. But it's important to remember that it's only the 15mm angled body in the range that does that. All the rest of them, you'll have to respect the flow direction arrow. So here is a commercial straight body, and that's got a clearly defined direction on it. Now if you get them around the wrong way, you're going to impede flow. And here is a single pipe body. Again, it's angled, but it's got the flow direction arrow. And finally here, the corner angle valves. These are the one that allows the head to be perpendicular to the pipework. When the pipework comes out of the wall, they've also got that flow direction arrow. So when you're specifying your corner angle valves, it's important that you know which direction the water is flowing in, because that will tell you whether you need to buy corner angle left or corner angle right. You can see here we've got the same body on each end of the radiator, because the water comes out of the wall, it turns right into the radiator, it then comes out of the radiator, and it turns right into the wall. This is a corner angle right body where the inlet is to the left. Now, if your flow is coming in on the other side, you're going to need a corner angle left. That is where the inlet is coming in on the right, so it comes out of the wall. It turns left into the radiator, through the radiator, out, and then left back into the wall. Corner angle left. And just to help visualize this, when using these, the pipe comes out of the wall into the radiator, but it allows you to still keep the head in an upright orientation. So I mentioned earlier that we have a valve body suitable for 10mm micro bore. Well, this is actually a 15mm angled body, so it's the same that you would get that's supplied with a 15mm olive, but instead of the olive, you have this bullet connector. Now you need to make sure you put them in the right way around so that when the nut goes on, it's flush with the bottom of the body, but that's now ready to accept your 10mm pipe. We also supply a range of lock shield valves. Now these can come as separates or in a pack, but everything from standard angled and straight to ones with drain offs. And we also do a tailpiece that has a drain off integrated into the middle of it, which, as well as providing a drain off location, these are also really useful if you need to increase the distance between the radiator and the valve body to accommodate existing pipework. And now to a look at our commercial radiator controls. So these are valve bodies that are designed to accept a BSP thread from a pipe. So they've all got female BSP threads in their respective sizes. They're available as singles, but you can also get them with lock shield packs. These are designed for 2-pipe systems, and we cover the majority of the most common sizes and valve body configurations. So for a closer look at one of these commercial bodies, this is a commercial straight, but you can see it still shares the same valve insert, so you're able to balance and change the gland seal. And these will be paired with a commercial lock shield. So instead of using a swappable cap to set these, you actually use a hex key down the slot. And now to our single pipe bodies. So these are designed for our single pipe system. They come in 1/2 inch, 3/4 and 1 inch, depending on what variation you want. And they are supplied as separate. So when you're specifying these, you have to pick both the body and the head as separates. Now these are quite large bodies, and they're much larger than their commercial equivalent. So if you had a 1/2 inch angled commercial side by side with one of these are going to be much bigger, because we're trying to reduce the amount of resistance to flow into the radiators, which is what you need for a single pipe system. And you can easily see the size difference when I hold a 15mm angled body next to it. And another feature of this is when we look into the ports, they are wide open. So they're not just a small drilling, these are wide open. So a feature common to all of these valve bodies is the fact they've got a replaceable gland seal that sits at the top of the valve insert. You can see it on all 4 of these. And to remove that or replace it, you use our pre-setting key. Now this key is what you use for balancing as well, but it's got the 2 prongs to get the gland seal out. Now the reason you might want to do that is over time, the movement of the pin will wear the rubber on the gland seal. And this is a secondary seal, and it's to prevent any water that gets past the first seal coming out. So over time, the pin wears the rubber. So we've made them so that these are replaceable. So you use the tool, insert the 2 D shapes into the top of the gland seal and turn it anti-clockwise. And then once it's out a little way, you can get your fingers there and it just comes out. And you can do this on a live system because it is a secondary seal. It's worth having some towels or something just to mop up if there are any drips, but there really shouldn't be. And then you can install your new one. These are sold in packs. And then screw it down until the top of the gland seal is flush with the top of the body. And you can see it's exactly the same principle on all of these that we've got here. Now I mentioned that this tool can also be used for balancing, and that is true on all of these except for the single pipe bodies, because you can see that whilst the gland seal is the same, the valve insert is different. And the way you go about balancing with these is you actually rotate the valve insert. Now you can see around the top of the insert there are stamped numbers, and these refer to different size apertures within the valve insert that when they're turned in front of the port will have an impact on flow. And to turn the insert, you need to first loosen off the clamp ring. So you use the appropriate end of the tool and you need to give the clamp ring half a turn. Now you don't want to take it all the way out, otherwise there'll be nothing holding the valve insert in and it could blow out because of system pressure. Once you've loosened it, flip the tool over and that engages into the top of the valve insert, and the numbers that are on the insert are repeated on the tool, and I've just highlighted these with a black marker just to make sure you can see them a bit better. But position 6 is the widest open. Now you must turn this insert clockwise so that if it picks up the locking ring, it's only ever going to tighten it. So you move from 6 to 1, that goes from the biggest to the smallest aperture. And then as you progress around from 1, 2, 3, all the way back up to 6, the aperture starts getting progressively bigger and bigger. And you need to make sure that the numbers are set on whole numbers, no half positions. And you'll see why when I show you the valve insert in a moment. So once you're happy with the position that it's in, you can then tighten the clamp ring back up. So take the tool out of the insert, flip it over, and give the clamp ring half a turn until it goes snug. Now, this pre-setting tool is quite versatile in so much as not only can you remove the gland seal and balance, you can also use it to disassemble the valve in its entirety. Now you're only going to be doing this on a dead system because you're going to actually remove the valve insert, but this begins by taking out the gland seal and then removing the clamp ring all the way out. And that means that there's nothing holding the insert in now other than the friction of the seal against the actual cast body. So you now screw these two prongs into where the gland seal was, give it a tug, and the whole insert will come out. Now you can see that the insert is made of plastic, and this is to give it non-stick internals, so it shouldn't suffer from calcification if you're in a hard water area, which can cause the valve to stick, particularly after a period of inactivity. A closer look at the valve insert bottom shows you the different aperture sizes. So there's number 1, 2, 3 and so on until you get around to number 6, which is the widest, and that's the one that's the default position when you get it out of the box. Now you can see here why you can't set it on half positions, because you'll have no flow whatsoever. The port is essentially blocked off. And so as we did in session 1 with the heads, let's have a look at the lineage of the TRV4. But in terms of bodies this time. So this really again is for reference if you come across them. TRV1 body is quite a smooth body, and you've got the circlip at the top. TRV2 body considerably smaller than the TRV1, considering it's for the same size pipework, and this has actually got a brass gland seal at the top. If you've got either of those that you need replacements for, you're going to have to replace the valve body. Moving on to the TRV3 valve body, which has got the identifiable cross on the top. Now if you're still running these and you need replacement heads, this is where you can get the TRV4C conversion head, so you can essentially put a TRV4 on a TRV3 valve body using that conversion head.
Thanks for watching this training video, and if you need any more information or resources, head over to our website, draytoncontrols.co.uk.